Hello everyone and welcome to the first video of the course ROS Basics. So in this video I'll be giving you a course preview and you'll get a glimpse of what you will learn throughout this course. So first of all, this is a platform by Robot Ignite Academy. So this platform is specifically designed to promote fast learning and efficient learning, and this platform is actually operating system independent. So all you just need is that a web browser and internet connection, and you need to type in robotigniteacademy.com and you need to select one of the courses to start with this platform. So you'll get to know about this platform along this video. So let's start with the course preview. So what do we need to learn to program a robot with ROS? So the first thing that we'll need is that we'll need to learn some basic concepts, and you learn those basic concepts as we pass on through this video. And the second thing, we'll need to know about topics. So topics are a very important part of ROS. So what topics are? All of the communication. What do we mean by topics? So what happens is that in ROS, all of the communications are handled by topics. So almost all important communication and even the more complex one rely on topics. So that's why topics are very important in ROS. So for example, in order to take the sensor readings, in order to communicate with your robot, we need to learn about topics. So in this simulator window, as you can see, there is a bot. This bot is named as Kobuki. So this simulator window will show us the simulation that's happening when we issue the commands through this web shell. And this is the file system, all the files you can see and edit over here. So during the course, during the series, will work with a lot of bots. So right now we'll work only with Kobuki in this video. So let's directly start with doing. So we'll learn ROS by actually doing. So let's try to move this bot circularly in a circle. So what we need to do is we need to issue a command, and we need to type in a command at this web shell. So the command is ROS launch publisher underscore example move.launch. So for the time being you can just ignore all this term ROS launch move.launch, and as will learn about this in more depth in the subsequent videos. So let's see what happens. As I press enter, the process is executed and the bot has started moving. So as you can see, the bot has started moving in a circle. So in order to exit the process, I need to press Ctrl+C. As you can see, I am back with the web shell where I can type another command, but the bot has still not stopped. So the reason I'll be telling you later. First, let's just stop this bot. So to stop this bot, we need to type ROS launch publisher ROS launch space publisher underscore example stop dot launch. So as the process is executed, as you can see, the bot has stopped. So now let me explain what I have done. So in the first command, that was move.launch, I issued a message through a topic cmd underscore, the topic name is cmd underscore velocity. So I issued a message to this topic, and the message was to make the robot move in a circular path. We'll learn about messages more in depth in the subsequent videos. So what happened was that when I exited the process, the bot was still moving. So why was that? Because the bot was still listening to the last message that was published to the topic cmd velocity. So don't worry about any of this messages and stopped files such as stop.launch. We'll learn everything in very much detail in subsequent videos. So as you can see, I then executed another command that was stop.launch. So that sent another message to the bot to stop it from moving. So the third thing we'll need to know about service, the third thing that we need to know to get going is services. So as we have already learned about topics, so does in reality the communication ROS only happen through topics? The answer is no. ROS also provides services. So what services does is that they allow us to code a specific functionality for our bot, and then we can provide a service to anyone, and that any other process can call a service. So for example, we can make a service that make my bot move for a specific period of time and then stop. Services are a little bit more complex since they are structured in two parts. So on the one side I have a service server which allows anyone to call it, and on the other side I have got a service client which actually calls the service. So let's see an example. So first I need to exit the stop.launch command. So there we go, Control+C. As you can see, I have exited, and so first I will have to start a service server. So to do that, I'll type ROS launch service underscore demo service launch dot launch. So it would do nothing on the simulator window because it has just created a server, and anyone can now any process, other process can call the service. So let me call the service by ROS service call /service underscore demo double quotes and close brackets. So what I'm doing is that I'm calling the service, as you can see, service.demo. So when I call the service, the code that's running behind this makes the bot move for 4 seconds. So now look at, I have still not entered the service, so let's just press enter. As you can see, I pressed enter and the bot has started moving. It will move for 4, yeah. So as you can see, it has stopped as well, and we have exited the service call. So now we have learned about topics and services. So the basic concepts you can are learning as we progress. So the fourth thing that we need to know is our actions. So actions are similar to services in the sense that they allow you to code a functionality for your bot, and and similar to services, anyone can call an action. The main difference between action and service is that when a service is running, the robot has to wait until the service is ended before doing something else. On the other hand, when we call an action, the bot can still keep doing something else while performing the action. There are other differences as well that are not needed at this time. We'll learn actions in very detail in the subsequent videos. So let's try an example. So first I'll have to exit all the processes that were running. Control+C, this is already exited, and Control+C, so this is exited as well. So I need to type, so again, like services, the action, first we have to launch an action server and then we have to call that action. So to start the action server, we have to write the command ROS launch action demo action launch dot launch. So there we go. So I have launched the action server. So now what I need to do is that I need to call ROS launch action demo underscore client space client underscore launch dot launch. So there we go. So again the bot will move for some time and stop. So there we go, stopped, and we have exited the process again. So what's very important in action and service is that we need to first start an action or service server by executing a command, and then we have to call it. So now we are done with topics, services and actions. So what's very important in ROS is that how to deal with errors. So what happens in most of the time that you will run into a lot of errors. So we need to learn how to use the debugging tools that are already present in ROS. So one of the most important debugging tool is RViz. So let's do an example and learn the working on RViz. So first I need to exit the action server. So there we go. So now I need to write ROS run space RViz space RViz. So there we go. So it has started. So what I need to do now is that I need to open a graphic interface. So it is, I'll click on this window button. There you go. So this is the RViz window. So as you can see, this is the robot model and this is all the display. So in this I'll already set up a fixed frame to base link. If you are not seeing any bot here, you can select from here and you can add and select robot model. That's there it is. Alright, so I already added it, so I won't add it again. So what we need to do is another thing is we need to add a laser scan. So there we go, RViz, and need to scan laser scan. So there we go. So press enter and maximize it, and you need to add a topic named Kyobuki laser scan. So there we go. So done. And zoom out. So what you'll see in your simulation is that you'll see a red line. I'm not currently seeing a red line because the bot is not facing the wall. So when the bot will face a wall, you'll see a red line that will show the laser readings. So that's all for this video, and in the next video we'll learn about ROS basics and we'll start with topics. So thanks a lot for seeing this video.